Okay, so in this example, we've got a constant vector field, a vector field that's always going towards the east, and we've got two paths. One that's walking from the origin eastwards, and one that's walking from the origin to the north. Okay, so we'll just sketch the setup. Okay, so here, we've got our constant eastwards vector field. We've got our path T0. Walks here. And we've got a path, or C1, we've got a path C2, walks here. Okay, so at the end of last lecture, we computed the path C1. We'll do it again as a refresher, and we'll calculate C2. Okay? So there's C1, C2. Okay, so for C1, we get the following thing. When we take the derivative r prime at t, we get this guy here. Right, when we take the derivative of the path C1, we get a 1 here and a 0 here. This guy. Okay, now we have to plug this point into our vector field. Our vector field is a little bit special though. Our vector field is constant. So anything that we plug in will just output 1, 0. Okay, so we get here. So now we're integrating 1, and we get 1. Okay. In this setup, as we walk along the path C1, we're traveling in the direction of the vector field. The vector field is pushing us along that path and doing some positive amount of work. Yes?
So you're dotting 1, 0 with 1, 0 there.
Yes.
Because the first 1, 0 is the value of the function, the second 1, 0 is the
Perfect. Yeah. So this is our r prime of t, and then this is our f of x, y. Okay, so one's the vector field, one's the derivative of the path.
Where did we get the second? Like, how did we get the derivative of this 1, 0 as well?
Oh, why? Where's this guy coming up?
Yeah.
Aha! Right. Yes. Right. So we've got a path that looks like this, and to get its derivative, we take the derivative of both components.
So it's just a coincidence that the derivative is the same value for the vector.
Yeah. It's just a coincidence that we get 1, 0, and 1, 0. We could, in general, we'd have some non-constant thing. Okay, so that's what happens when we walk along C1. Right, when we walk along C1, the vector field pushes us. What about when we walk along C2, and we're walking perpendicular to the direction of flow? So now we'll set up C2. So for C2, here, in that case, our R prime comes from this guy. Right, so we take the derivative of our path. This time we get 0, 1. Okay, this dots to 0. Now we're integrating at 0. Okay, so two things to notice here. On the C1 path, the flow of the river helps us. It does a positive amount of work because the path is correlated with the flow of the river. On the C2 path, it's totally orthogonal to the flow of the river. The river is not contributing to our travel in any way. Okay, so not contribute. Here, somehow the vector field helps us.